So, welcome and good morning. Time for some stories from the wild and looking at underneath the hood why things sometimes doesn't work. So, I'm Anders Abel, Swedish consultant, and I work a lot with Duende Identity Server and do consulting and training for Duende, but I also do other things and see other providers and see some comparisons. And different providers have different strengths and weaknesses. So we'll look at that. First of all, I want to look a bit at specification, because this is a space that is extremely spec-driven. And the original spec is RFC 6749 OAuth2. If you want to upset someone working with OAuth2 and OpenID Connect, go and ask them, what about login, using OAuth2 for login? Because the thing is that OAuth2 is all about getting an access token to call APIs on behalf of the user. OAuth2 has no idea about a session. And logging in means establishing a session. And eventually, as we'll talk about later, we probably also will single log out to tear down that session when we are done with it. That's not part of OAuth2. So OpenID Connect was added as a layer on top of OAuth2. And OpenID Connect provides secure session establishment and session management and session teardown in the logout phase. Going to the OpenID Connect page, it turns out that, well, OpenID Connect is not just one spec, but a bunch of specs to keep track of, and some of them are published by separate working groups for reasons, I guess. So, looking here, it looks simple. I mean, RFC 6749 is just one spec, isn't it? Well, OAuth2 is like, hey, hold it for me. I have some companions. I think this is the current list of OAuth2 specs. Most of these are extensions with new functionality, adding higher security profiles or adapting for different kind of applications, things like that. But a couple of them are actually crucial security fixes to the the original flow, and these are things that everyone actually implements, or should implement at least. Is the RFC 7636 proof key code exchange that fixes risk for code substitution attacks, especially in mobile devices, and RFC 9207 authorization server issue identification that it also fixes a kind of substitution attack. But this means it's not that simple for an implementer to keep up. So let's look at one thing that matters, token size. So I've done a fair bit of conference talks. This was NDC Oslo last year. Dominic Meyer saw this picture and said, hey, that looks like a phishing story. Are you talking the token was this big? And I hope not, because tokens should probably not be big. So I found this picture of someone else. He has a better grip of the token size, obviously. So why do we want small tokens? If we look at a typical example of a web application that wants to authenticate with an upstream provider, we want to log in. When we do that, we get an access token and an ID token back in OpenID Connect. Then we typically set some cookies on the client application to establish a session. Then we might want to call an API. And to be able to call an API, we need to send the access token along, so we need to keep the access token on the client application. And it turns out we also need to keep the ID token, because to prevent cross-site request forgery attacks on logout, there used to be something called logout spam, where you went to page watching a picture of kittens or something, and in hidden iframe they just rendered logout endpoints for a bunch of providers of popular sites on the internet. So after you had been there, you were suddenly logged out everywhere. It could be seen as a prank, but it actually is also can be part of an attack. So for example, if you have an attacker that they have found an attack a way to attack you in the login phase, then being able to log users out means they have to log in and then they can execute their attack. So since we need to keep the tokens around for the duration of the session to be able to log out and call APIs, we want them small. This is a token coming from Microsoft Entra ID. It's an somewhat abridged version, but it's a real token. What we can see here is the groups. In this case, I have 4 groups. That's not many. But one of the features with Entra ID is that you can nest groups in each other. So you can have groups that are members of other groups, that are members of more groups. There is no way to express that with nested groups here. So Microsoft Entra ID just expands the list before it dumps it in the ID token. In a large corporation, it's not unusual to have people where the expanded list of groups is in the hundreds. And having hundreds of those, yeah, that turns out to be a problem. And Entra ID actually realized that. To ensure that the token size doesn't exceed the HTTP header size limits, the number of object IDs that it includes in the groups claim is limited. Good. They put a limit to it. 200 for JSON Web Token. I think that 200 object IDs, then the token is probably already a bit on the large side. So what to do about that? Well, there is a mechanism in OpenID Connect called the user info endpoint. The idea is that you send in the access token and you get actual payload information about the user back. The good thing with this is that we can now reduce the ID token to be just the protocol details that and security measures that is needed to prove the identity of the user. And in the end, we just have the subject ID in there. And all the given name, family name, display name, group membership, all of that goes, it has to be fetched over the user info endpoint. Another good thing with the user info endpoint is that you can actually query it whenever you need. So the ID token is something you just receive on session initialization. For a long-running session, if things are updated, you cannot update unless you log in again. While if you use a user info endpoint, you can update whenever you want. So the user info endpoint is a critical mechanic thing or a critical feature in OpenID Connect to make token sizes manageable and avoid all sorts of issues. So let's look at the Microsoft Entra ID user info response. This is an example they have from the docs. And then it says, the claims shown in response are all those that the user info endpoint can return. These values are the same values included in an ID token. Okay, hold on. So they have the user info endpoint, but they still put everything in the ID token. Okay. But we could at least update things from it. Well, noting caveats on the user info endpoint. You can't add to or customize the information returned by the user info endpoint. To customize the information returned by the identity platform, use claims mapping and optional claims to modify security token configuration. I feel that the user info endpoint implementation by Microsoft Entra ID is one of those that we had to do it according to the spec, and they did the minimum thing. What upsets me a bit more is that they saw the text that it limits the number of tokens, but it indicates to the application to query the Microsoft Graph API to retrieve the user's group membership. So obviously, server-side, they have all the data. They even provide an endpoint or a feature to query that through the Microsoft Graph. But why didn't they just hook up the user info endpoint to that? No idea. Guesses are welcome. So let's look closer at the token size at logout. If we have a web application with a logout button, and then redirect the user to the end session endpoint of the provider, identity server will respond with this. Would you like to log out of identity server? Yes. And then the reason for this is because of cross-site request forgery risk. The logout endpoint is a GET request, and we need to somehow, anyone could redirect the user there. So we need this. This is a form post that prevents, it contains proper anti-forgery tokens to prevent cross-site request forgery. And but it's an awkward user interface. I mean, I press logout. That button should also have proper cross-site request forgery protection. So somehow, if we could authenticate the user, and that's where the ID token comes in. If the ID token is sent along with the logout request or logout redirect, then identity server will no longer show this. And it also enables identity server to know what client application initiated logout, because the client ID is in the ID token in the audience parameter. So that allows identity server to redirect back, and now we get a decent user experience. Hitting logout means redirects and some screen flickering maybe, but in the end you can map in the application where you click logout. This is how it should be done. Aren't ready? Well, they always show this. Pick an account. Which account do you want to log out of? Even if you supply an ID token hint or logout, they still show this one. And I mean, the client application sends in an ID token, which contains the identifier of the user and what client application was requesting logout. The identifier of the user is there, and OnTryD says, hey, I don't understand. Which one do you want to log out from? And actually, it doesn't matter. It's the same experience, regardless if you send in the ID token hint or not. So you went out and tested. What about redirection back to the client app? What if we have two applications in the session? Turns out that there's no connection between the application where I initiated logout and what accepted it, where it accepts redirect. So one application can easily redirect to another one on logout. And the protocol spec prevents this. The protocol, well, if you follow the protocol spec closely, the post-logout redirect URIs should be pre-registered per client application. So let's talk now about another thing, about issuer. So this is just an example from identity server. The spec contains a mandatory requirement that OpenID providers supporting discovery must make a JSON document available at the path formed by concatenating the string /.wellknown/OpenID configuration to the issuer. This is a brilliant thing in OpenID Connect, because it means if we take a token, we have the issuer in there, then we could go get the discovery document, from the discovery document, get the public keys used to verify the token. So just having a token, if everything is spec compliant, we can use that to get the information we need to be able to validate it properly. If we, for example, take demo.software.com, add /wellknown OpenID configuration, we get this link. And if I click that one, we will get a discovery document with, for example, the JORCs URI, where we'll have the public part of the signing key. And we can see the issuer in there, because there's also a requirement that the issuer identifier for the OpenID provider, which is typically obtained during discovery, must exactly match the value of the ISS claim. This is when validating tokens. So there's a very strict requirement that these things should all be consistent with each other. Doesn't look too hard to get right, does it? Do you think anyone could ever get this wrong? Welcome to OnTriD. So if we have this login microsoftonline.com with a tenant specified, so this is my test tenant ID. I add the well-known OpenID configuration, I get this one. Let's go there and see. So what we would expect now is the issuer should be login microsoftonline.com/1c23, etc. And if we go here, they don't put the issuer on top. I think they kind of want to hide it somewhere. It's here. STSWindows.net. This is actually okay according to the spec, because the initial URL here, loginmicrosoftonline.com, is just an authority URL that they supply. They say that there's nothing that says that you cannot serve the discovery document on more locations. But the interesting question here is obviously that we found this issuer, if we append well-known OpenID configuration to be spec compliant, we should have the discovery document on this URL, because this is the one that we would go read. Yeah. We have discovery document, and actually the issuer this time matches. But I was a bit surprised to find this even in the single tenancy mode. But then we have a bit more complex things. So when using Microsoft OnTriD, an application typically not, or often not only authenticates to one instance of OnTriD, but to many. This is, if you're a software as a service provider, you would have your own OnTriD tenant, but you also want to be able to federate with your customer's provider. And of course, you can have your client application be registered as an app registration in every single OnTriD of all your customers. Then you need to talk to them, get the redirect URIs right, get the client secret right, update the client secret on occasional intervals, things like that. And Microsoft, they're all about simple onboarding. I mean, OnTriD is sometimes used by small organizations. They don't have the resources. They just need a simple way to get onboarded. And they have this concept where you can publish an application in your tenant and make it available to others. And then all the configuration data remains in your if you want to change the redirect URI, you can just do it in your settings, and it will they will not have to update on their side because they are essentially using your app. So instead of having your application communicating with all of these logical upstream identity provider, why not add a new one? And that is exactly what Microsoft did. They added a new kind of virtual instance that can authenticate to all of the others. How did they do that? They have a separate authority, loginmicrosoftonline.com/common. If you use this authority, it means that, hey, I want to be able to access any, or this application is allowed to be accessed by anyone in any OnTriD tenant. We'll do the same, well-known OpenID configuration. Let's see what we have here. The issuer is also definitely hidden a bit further down. So what's this? Looks like a template string. There's no such thing as templating in the spec. The spec says it must be an exact match, right? Okay. Yeah, and we have the same thing with STS tenant ID. So let's try this then. You should be able to take the issuer and do /.wellknown, right? Invalid tenant. Tenant ID was not found. Obviously, no. It doesn't work that way, and it's more and more obvious that tenant ID in the squirrely braces is a template. So let's go back and try. Let's just put in common here and not a tenant ID, see what happens. We got something, and now again we have the issuer being the template. So yeah, well, I went ahead and created an application using multi-tenanted. I logged on, and this is the resulting ID token I get back. And as you can know, I don't read encoded ID tokens either. This is the decoded ID token. We had just the normal header, and then we have the payload. And what we can see here is that even though the authority I started with was this common endpoint, or where it said the tenant ID, the issuer of the token is the actual tenant ID of my account. They also supply the tenant ID as a claim. I have no idea why. Because we have it both in the issuer and tenant. So to summarize a bit, we go and fetch the discovery doc. We find the issuer with this template string. The spec says that the issuer identifier for the OpenID provider, which is typically obtained during discovery, that is read from the discovery doc, must exactly match the value of the ISS claim. We get this ISS claim back. So we can't be spec compliant if we want to work with OpenID multi-tenanted. We have to remove this. And then we get the tenant ID as a separate claim. So I went to an actual production application I have access to and checked that I know use multi-tenanted OpenID and checked, how do they do this? Well, this is actual production code. Validate issuer false. Which is perceived probably not unsecure because it relies on the fact that the signing keys are owned by Microsoft OpenID, and they have the same signing keys for everyone. So essentially, we just fetch the signing keys from one tenant, and then we can use those to validate tokens regardless of what tenant they are issued by. Still not what I would prefer. So let's see, what would I have done? Because I've given some thought to this. So if we look back at our graphical representation, the problem is that we are initiating the signing into this virtual common in OpenID provider, but then the response is coming directly from the actual providers. This would be a much better thing. We could have a virtual provider where our client application would interact with the same one, and the issuer would be this one, and then we could just have the tenant ID as a claim. Or why even have this virtual one? I mean, one of these is our home tenant. This is where the app registration is created. Why not let this one just connect to the rest of the logical instances? And if we rearrange it and add a couple of more client applications, this is the federation gateway pattern. That is an architectural pattern that I often recommend for when working with OpenID Connect. This would also solve another problem, probably, where it's not possible to use OpenID guest accounts in the setup. I think it would be possible here. Okay, so let's take another example of issuers, because unfortunately this is not the only time Microsoft has done interesting things to issuers. This is ADFS. I once had a project where, for reasons, they wanted to use Microsoft ADFS together with Azure API management. I mean, two Microsoft products, right? It's just that one is from the on-premise legacy era, and one is a modern cloud product. And obviously, Azure API management is designed to work with Azure AD or OpenID. I actually met one of the API management developers on a conference, and told him about this story, and he was like, "Why would anyone do that? Why would anyone use ADFS with API management?" But yeah, for reasons. We have the issuer here, adfsexample.org/adfs. I think they created this URL as the issuer to allow the discovery document to follow the pattern of other paths in ADFS. But then we have another one, access token issuer. So it's actually using different issuers for the access token and for the ID token. And if you have a normal client library, an API, in an API that downloads the discovery document, it will go and check the issuer. So you would have to do that. There is a way to fix this though, because I have no idea where this comes from, but this is the Federation Service Identifier. And the Federation Service Identifier is possible to configure, so you can change the Federation Service Identifier to be the same as the top one. Just one drawback, that is kind of the global identifier of the ADFS instance. So typically if you have the ADFS and want to add OpenID Connect to it, it's typically because you have had a ton of legacy applications already using ADFS with WS Federation or SAML2. And now OpenID Connect requires you to change the Federation Service Identifier, which will break all of the existing client applications. If you set up a new one, yeah, it's an easy thing to just make sure these match. But still not exactly what I would prefer. One thing that OAuth2 can handle, though, as we've seen, is logout. We could do logout. Let's talk about logout a bit more. So if we have a session in an application that we've created here, we have a session represented by cookies. We typically have cookies on both sides. So we have one session in the client application, we have one session in the identity provider. If we hit logout and simply remove the local cookies, and the user then tries to access a protected resource, typically a single sign-on flow will be initiated or log on to identity server, and it will just get the cookies back. I mean, I would love this to be in the cookie jar at home because my kids eat the cookies. So what if the cookies could just reappear? Wouldn't that be good? No. This is when I started working with single sign-on, this was an actual bug report we had in a production system, healthcare in Sweden, where the IDP login there was a session and there was also a smart card involved, which meant that as long as the user had the smart card in the terminal, single sign-on would work. And if they removed it, the session cookie could remain in some cases. We had implemented single logout in our application, but single logout was not implemented, which meant that we just cleared our own cookie. And then we had one user, healthcare professionals, you know, they are people that really take this seriously and make sure that when they are logged out, she went and clicked a link just to see, can I still access the patient record? And this happened. So if we have single sign-on, we need single sign-out always. Without single logout, there is no re-logout because you can just be re-logged in. If we look at a discovery doc from identity server, we will see that there is an end session endpoint that is where we redirect the user. There is another platform that is fairly popular. Anyone heard about Google? They have a discovery document which is actually fairly short. If I just collapse these, I think we might even get to the end. Yeah, it's short. Anyone see the end session endpoint? Let's search. No. No end session endpoint. Well, you can log out to your Google account, but you have to go to accountsgoogle.com and initiate it manually. Google obviously do not want users to log out. And I think this makes sense. On my personal phone, my personal device, I just stay logged into my Google account. That's fine. But what if I borrowed your device to do some urgent work and hand it back? I think that I pressed logged out before I hand the computer back. I mean, everyone in this room, we know that if we borrow a computer from someone and log in, I would do it in an incognito window to ensure that I can close it and be sure that everything is really gone afterwards. But a normal user wouldn't do that. A normal user would probably just log in, hit log out, and think it's secure. So to me, this is a security issue. That is the same. Okay, let's talk a bit more about lacking features. And now we are moving from protocol level and spec level things more to architectural concepts that we might need. This is the architecture from a company. It was a startup. I think it was 15 years ago, so it's a long time ago. Or nearly 15 years ago they started, and they get some. There is a program from Microsoft where startups can get cool infrastructure and even some consulting help from Microsoft's consultant to get the architecture right. Azure AD B2C was new at the time, so they decided that they wanted to use Azure AD B2C because from a trust perspective, it's a good idea to say that no, we don't have credentials of any users. We use Microsoft. They are an established company and they handle all passwords. We don't do that ourselves. They also had to support other providers. So this is a combination of consumer accounts and business-to-business federation accounts in this application. So the Microsoft consultant that was obviously paid to plug Microsoft products said that we should use Azure AD B2C. It's new and it's good. But then we have the client application. We need to issue access tokens and use access tokens to call APIs. And Azure AD B2C can't really do that. So let's use Identity Server in between. My question here is, why Azure AD B2C at all? Azure AD B2C also has a few more quirks with, they have something called a policy where you can have a sign-in policy or a sign-up flow policy, and they are defined by starting at different endpoints, and that is actually reflected in the token produced. So depending if the user signed up, recover the password, or just signed in, you will get different issues from the token when it comes back. And we saw what the spec says about token issues. Another one that is interesting. This is something I've seen a lot. In this customer case, it was Okta, but I've seen it with other providers. I've seen it with OnTryD, I've seen it with OAuth2, the non-Okta OAuth2 as well, and AWS Cognito, I've seen the same. Where we have something that on the surface looks like a good architecture, where we have two client applications using a shared API. They use Okta for single sign-on, Okta federates with multiple upstream providers. But then on the architectural drawing that this customer supplied, there was something more. There was the ID translation layer, which was an internal service they used to translate whatever came from Okta to their internal identities. And in typical architecture, if we look at the Federation Gateway architecture, we had it previously here. Let's get back to it. If we look at the Federation Gateway architecture, the role of the Federation Gateway is to shield the client applications from all of that. So the client applications should get a unified internal definition of the identity from the Federation Gateway, and then it's up to the Federation Gateway to interact with the upstream providers and translate. It turns out that Okta in this case couldn't really accommodate to all the requirements they had, so they had to insert another one. And this is something I've seen every now and then with various cloud providers, that they cannot accommodate and be flexible enough. OnTryD definitely too. But I have an even worse story about something like this. This was a customer using AWS Cognito for their web app, and actually my customer was this web app. Then the customer's customer had this set up. So I was working on that web app, and the end customer came and said that, hey, we want to migrate to AWS Cognito, so we need to be able to use that. And we'll connect our AWS Cognito instance to our CRM system with the idea that users would be able to use Google and Facebook to sign on, but there was also a connection to the CRM system saying that only users that actually existed in the CRM system and had an existing relationship with this organization would be allowed to to log in. They essentially wanted this, that if you try to log in and you're not in the CRM system, you would be redirected and stuck on the CRM system on a registration page where you could request registration and then be let in. It turns out that AWS Cognito, they could get it to pick up the identifier from the CRM system and query the CRM system for it, but they couldn't make it to alter the flow. So in the end, we ended up with this, where we had to implement code on our side in the client application all the way down, where we checked, do we have a CRM ID claim on the user coming in? And if not, we had to block them and redirect them back to the CRM, but they already had an established system. So once more, the cloud providers, they are excellent at what they do, but if you want anything more than exactly what they do, it often results in quite awkward hacks. And I used to say that for OAuth2, for example, if you need a square box, OAuth2 is a perfectly well-polished square box. Same goes for OAuth2, for example. It's a well-polished square box. But if you want to change anything, I mean, OAuth2 is like the T-Ford. It comes in black, period. OAuth2, yeah, you can probably change color of it. But if you want to really adjust it, it's not possible. You need another solution. So I've been bashing so far products and telling about some incompatibilities that I've met. But as a final thing, I have actually something from the spec. So even though I like the specs are not perfect. OAuth2 basic auth. Let's start with RFC 7617, which is just a clarification of RFC 2617, basic authentication for HTTP. It says that get the user ID and password from the user. Construct the user pass by concatenating the user ID, a single colon character, and the password. Note the colons are not allowed in the username thanks to the scheme. They can be in the password though. Encodes the user pass into an octet sequence and typically UTF-8. Obtain the basic credential by encoding this octet sequence using base64. So it's just UTF-8, base64, done. In a flow where a client needs to authenticate on the back channel to, for example, the token endpoint on an OAuth2 authorization server, the client can use basic authentication. And it's even described a bit in the RFC 6749 OAuth2 basic auth. Well, this. The client identifier is encoded using the application /xwww form URL encoding algorithm. The client password is encoded using the same algorithm and used as the password. We recently had this as a bug. Someone saying that, hey, why don't client secrets that contains a plus character do not work with identity server? The reason was that this customer used basic authentication as it was a standard, defining the standard. Identity server supports the full one, and plus has a special meaning and is actually in xwww form URL encoded. Plus is actually encoding for the space character. So it doesn't work. And I'm like, but why? Why does OpenID OAuth2 have their own definition? They don't really make it easy for us, right? So that's actually all the stories I had prepared. And we have some time if you have questions or if anyone has more horror stories to share, I would be happy to hear them. Everyone, you just use spec compliant providers, do you? They just work. Well, thank you so much for being here and hope you have a great day at the conference.